Question number 7 says, if 2 log to base x of 27 all over 8 is equal to 6, you find the value of x. If you look into this and if you try to apply the third law of logarithms, you find out that this means log to base x of 27 all over 8 squared, and it's equal to 6. Now, if you also apply what I gave you as an assumed fourth law of logarithms, you discover that x raised to the exponent of 6, which is in this side of the equation, is going to give you 27 squared all over 8 squared. Remember, what this means if you remove brackets is 27 squared divided by 8 squared. I want you to multiply out this using the calculator. 27 times 27, giving me 729. So we have that x exponent 6 is equal to 729 all over 8 squared is 64. So all over 64. Now you have an exponent in the left hand side with a base x. Try to convert what you have on the right hand side of the equation in such a way that we have the exponent of 6. What do I mean? Find a number that if it multiplies itself 6 times, you will get 729. And another number that if you multiply it 6 times, you will get 64. I'm looking at 3 for 729 and 2 for 64. Let's try it. 3 times 3, that is 2, times 3, 3 times 3, 4 times 3, 5 times 3, 6 times is equal to 729. That means in the numerator we're going to have, first of all, write down x exponent 6 is equal to 3 exponent 6. Now divided by, let's try 2 for 64. 2 times 2 is 2 times 2, 3 times 2, 4 times 2, 5 times 2, 6 times is 64. That means here we have 2 exponent 6. In this case, what this means is bring down x exponent 6 is equal to 3 all over 2 exponent 6. That's the meaning of this. Now that you have the exponents, remember in our previous practices, we'll be having the same basis and we have been equating the exponents. In this case, we are having the exponents. That means we will drop the exponents and equate the basis. Now you then have that x is equal to 3 all over 2. And 3 all over 2 in mixed fraction form becomes 1 whole number 1 all over 2. And that gives you the answer to that question. Question number 8 says, simplify log root 5 all over log 5. The first thing you do here is you're going to change the square root of 5 into an index form. And in so doing, you're going to have that log root 5 will now become log 5 exponent 1 all over 2. This is the index way to write the square root of 5. Bring down the denominator, log 5. If you look close now, you discover that if you apply the third law of logarithms, log 5 exponent half will now become half log 5. Bring down the denominator, log 5. As you have this now, you can cancel log 5 up and down. I'll be left with 1 all over 2 as the answer to the question. Question number 9 says simplify log 8 minus log 4 divided by log 4 minus log 2. What to do here is this. You try to change all these figures to a particular log and then descending them to their factors. And the factors that is going to work here is descending them to their factor of 2. You know that 8 is 2 exponent 3. 4 is 2 exponent 2. The same thing, 4 is 2 exponent 2. And 2 is 2 exponent 1. So we are going to reduce them to the basis of 2. What do I mean by that? Log 8 becomes log of 2 exponent 3, because 2 exponent 3 is the same thing as 8. Now minus 4 becomes, log 4 becomes log of 2 exponent 2, because 2 exponent 2 is 4. Divided by log of 4 is, will now become log 2 exponent 2, then minus log of 2 remains log of 2 exponent 1, if you like. What this means is 3 log 2. Applying the third law of logarithms. Minus this will now become 2 log 2. Divided by, this will be 2 log 2. Minus, this will be 1 log 2. 3 log 2 minus 2 log 2. It's just like saying 3x minus 2x. You'll be left with 1 log 2. So in the numerator you have log 2. Now divided by 2 log 2 minus 1 log 2. It's just like saying 2x minus x. Here you will also be left with log 2. So we have log 2. Log 2 divided by log 2 will give you 1. That means 1 becomes the answer to that question. This is the 10th question. And that question says we should evaluate log of 8 divided by log of 4. What this means is log of 8 over log of 4. All over log of 4. As usual, try to dissect 4 and 8 to have a particular base and an exponent. You and I know that 8 is 2 times 2 times 2. That means 2 exponent 3. Whereas 4 is 2 times 2. That means 2 exponent 2. Write it in that form. Log 8 becomes log of 2 exponent 3. Whereas log of 4 becomes log of 2 exponent 2. In practice and obeying the third law of logarithms, log of 2 exponent 3 is the same thing as 3 log 2 divided by log of 2 exponent 2 is certain as 2 log 2. You now have 2 log 2. At this juncture, you can do away with log 2 and you are left with 3 all over 2. And 3 all over 2 in mixed fraction form is 1 whole number 1 all over 2. And that is the answer to that question. This is question number 11. It says we should rewrite log x minus log y is equal to log z and make x the subject of the formula. If you look at this expression, you discover that if you apply the second law of logarithms, log x minus log y will become log x all over y. Second law of logarithms. From here you get this. From here you can also get this. Then it's equal to log z. After this, since you have log x all over y is equal to the same log of z, you can remove log. Just like having 2 times x is equal to 2 times y. You are free to remove the 2 that is common in both sides of the equation and equate the things that follows the 2. That will now give us x all over y is now equal to z. The question said we should make x the subject of the formula. So let's write z as a fraction. We are going to have x all over y is now equal to z all over 1. At this juncture, if you cross multiply, discover you have x times 1, which is x, will now be equal to z times y, which is yz or zy. And that has brought us to the end of that question. Question number 12 said we should rewrite log x plus 2 log y is equal to 3. We are going to change 2 log y respecting the third law of logarithms. After which, we will change log x plus whatever we get as the value of 2 log y respecting the first law of logarithms. Let's first of all change 2 log y. So we're going to have log of x plus 2 log y respecting the third law of logarithms means log of y exponent 2. Everything is equal to 3. Now, log x plus log y exponent 2. If you respect the first law of logarithms, discover that the meaning of this is log of x times y squared. This means this, and this means this in the first law of logarithms, and is equal to 3. 3. First of all, I had told you that whenever you are dealing with log and there are no base attached to them, they are in base 10. This 3 has the value of log of 1000 to base 10. I want to explain that. Log of 1000 to base 10 means log of 10 exponent 3. You know that 1000 is 10 exponent 3. You know that. 10 times 10 is 100. 100 times 10 is 1000. That is why 10 exponent 3 means 1000. In this case, if you should apply the third law of logarithms, you discover that log of 10 exponent 3 to base 10 is the same thing as 3 log 10 to base 10. 3 log 10 to base 10. The log of any number, if you still could remember what I told you, that should be an assumed fourth law of logarithms. The log of any number to the base of the number is 1. The log of you watching me to your base is 1, if you can be brought to the whiteboard. That means that log of 10 to base 10 is 1. And what you have here now is 3 times 1, which is 3. Have you seen why I told you that 3 has the value of log of 1000 to base 10? So we are going to exchange 3 to log of 1000 to base 10. We are not going to write base 10 because in all this scenario, there is no attachment of base 10. But we know that they are on base 10. So we're going to have log of x y squared is equal to log of 1000. You can remove log and remove log. Just like saying b times x y squared is equal to b times 1000. You are free to remove the b, which is common in both sides of the equations. We are now having x y squared is equal to 1000 to be the answer to the question. Had it been that the question went ahead and told you to make any of these x or y the subject formula, you continue from here to make any of them the subject of the formula. But now the question is silent in that area. So the answer remains x y squared is equal to 1000. Question number 13 says, if log x minus log bracket opens 2x minus 1 bracket closes is equal to 1, that we should find x. Don't worry. They will keep on telling us to find x. They will keep losing x and keep giving us the assignment to find x. We'll keep finding x. If they cannot pay us here for finding x for them, we will get to heaven. God will pay us. So let's find x for them here. So in this case now, let's apply the second law of logarithms so as to simplify this bogus thing. Log x minus log bracket 2x minus 1 means, respecting the second law of logarithms, log of x divided by 2x minus 1. And it's going to be equal to 1. 1 means log of a number to the base of the number. In this case, there is no base attached to the logs. That means they are on base 10. That will give me the attorney to tell you that 1 means log of 10 to base 10. So I'm changing 1 to become log of 10 to base 10. So I'm going to have log of x all over 2x minus 1 is now equal to log of 10. Log times this, remove log. It is not needed. Equate x all over 2x minus 1 is equal to 10. So we're going to have x all over 2x minus 1 is equal to 10. We can write 10 in fraction form to be 10 over 1. If you cross multiply here, you find out you have x times 1, which is x, will now be equal to 10 times 2x minus 1. 10 into 2x minus 1. Remove this bracket. X is left in the left-hand side of the equation. 10 times 2x will give you 20x. 10 times minus 1 will give you minus 10. Collect like terms. You are to move this 20x to the left-hand side of the equation to meet its counterpart, x. That will leave you with x minus 20x. Remember, when positive 20x leaves the right-hand side of the equation and crosses the sign of equality, its gender will change. And the gender is, it will change from positive to negative. That's why you now have x minus 20x. It will now be equal to minus 10. X minus 20x will leave you with minus 19x. And is equal to minus 10. divide both sides by minus 19, so as to have only x left in the left-hand side of the equation. When you do so, you'll be left with only x here after you have divided minus 19x by minus 19. And it's going to give you minus 10 divided by minus 19 in the right-hand side of the equation. X will now become minus, we cancel minus, you'll be left with plus 10 all over 19. If you like, you can use a calculator and find this value in decimal form. 10 divided by 19 is giving me 0.5263. This is the answer to that question. Evaluate. Bracket opens 2 exponent x, bracket closes exponent 2, minus 3, bracket opens 2 exponent x, bracket closes, plus 2 is equal to 0. This is the type of questions you get in your external examinations. The truth is that this expression, there is no formula obtainable anywhere to decode it. What you do is you try to shift it from its nature to the nature of an expression that has a formula. And that expression that has a formula you should change it to should be quadratic expression. That is one thing you must do to change this expression into a quadratic expression. And that is that all the things you have inside the bracket which are alike, substitute them to any letter you like. Inside this bracket you have 2 exponents x. Inside this other one you also have 2 exponent x. Substitute them to any letter you want in the alphabet. Let's take x. Use x to substitute 2 exponent x in here and 2 exponent x here. 2 exponent x becomes x. Bring down the squared. You have minus, bring down 3. 2 exponent x will be x. Bring down plus 2 is equal to 0. You cannot see that this expression has been changed to a quadratic expression and the value are still the same thing. Now factorize this for you to be able to find the value of x. In factorizing a quadratic expression, first of all create 2 brackets in this form. X squared means x times x. Split the 2x that multiply themselves to get x squared in the beginning of the 2 brackets that you created. After that, find 2 numbers that have the product of 2 and sum of minus 3. 2 numbers that if you multiply them together you get plus 2. If you add them together you get minus 3. Minus 2 and minus 1 satisfies it because minus 2 times minus 1 will give you plus 2. Minus 2 plus minus 1 will give you minus 3. So this satisfies that. If you multiply add this bracket, you get back this expression. I know you know how to do it. This is going to be equal to 0. We're bringing down equal to 0. If 2 things are multiplying themselves together to get 0, one of those things must be 0. And it is based on this principle that we can find the value of x now. X minus 2, the one you have inside this bracket is 0. Or x minus 1 is 0. If 2 of them must multiply themselves together to get 0, one of them must be 0. In this case, if x minus 2 is 0, that means x is equal to 2. Or if x minus 1 is 0, that means x is equal to 1. So x is either 2 or 1 is the answer to that expression. Question number 15 says evaluate 2 in a bracket exponent 2x minus 10 bracket opens 2 exponent x bracket closes plus 16 equal to 0. Just like question number 14 that we just concluded, there is no formula that could be applied to it direct like this at this level. Try to change it to an expression that has a formula that can be applicable, and that expression is quadratic. Before you change it to quadratic, first of all rearrange this. 2 exponent 2x, it's something as 2 exponent x2, because already in this other bracket you have 2 exponent x. So arrange this in such a way that the x will come before the 2, so that when you are substituting what you have in common in the brackets, it will be clearer and not confusing to you. So the expression becomes 2 exponent x bracket closes exponent 2. That's the meaning of this. Minus 10 into 2 exponent x, the one you have here, plus 16 is now equal to 0. Choose any letter to substitute the values which are the same thing that you have inside the brackets. In this case, let's use y. Use y to substitute the things you have inside the bracket. You are going to have the expression to be y squared minus 10y plus 16 is equal to 0. This is now a quadratic expression. So factorize this quadratic equation. In factorization, you provide 2 brackets in this form. Y squared means y times y. Split the 2 y that multiply themselves together to get y squared into the first space or the initial space of the 2 brackets you provided, just as I have done. Find 2 numbers that have the product of 16 plus 16 and sum of minus 10. 2 numbers that if you multiply them together you get plus 16. If you add them together you get minus 10. I'm looking at 8 and 2. 8 and 2. Minus 8 times minus 2 will give you plus 16. At the same time, minus 8 plus minus 2 will give you minus 10. So we are correct. Remember, this is equal to 0. If 2 things must multiply themselves together to get 0, one of those things must be 0. And based on this principle, we can find the value of our unknown, which is y. If y minus 8 times y minus 2 is equal to 0, that means either y minus 8 is equal to 0 or y minus 2 is equal to 0. In the case of y minus 8 is equal to 0, y will be equal to 8. Moving minus 8 from the left hand side of the equation to the right hand side, you change plus 8. And if you add plus 8 to 0, you get 8. Or in this case, y will be equal to 2. Taking minus 2 from the left hand side of the equation to the right hand side, you change to plus 2. And if you add plus 2 to 0, it will give you 2. So the value of y in that expression becomes either 8 or 2. I would like us to use this question number 16 to close our discussion on indices and logarithms. In this case, the question is unique. We are asked to evaluate log to base 2 of 6 using tables. Remember, we've been evaluating without using tables. Pay attention. When you are given this, try to create an equation with this. Creating an equation is equate this to a letter and start from there. That means you write that let the expression given to you, log to base 2 of 6, be equal to any letter. Let's use x. If log to base 2 of 6 is x, respecting the principles and condiments in logarithms, the ideas, technology in logarithms, it means that 2 exponent x is equal to 6. At this juncture, it's like you are running away from the logarithms. Introduce back the logarithms. You will now have that log 2x, log to any given base 2x is equal to log to the same base of 6. Now that you don't have any base attached, remember I told you they are in base 10. Log to base 10 of 2x means x times log to base 10 of 2. And it's going to be equal to log to base 10 of 6. If you want to have only x left in the left-hand side of the equation, that means you have to divide both sides of the equation by log 2. When you do that, you'll be left with only x in the left-hand side of the equation, and it's going to be equal to log of 6 to base 10 divided by log to base 10 of 2. Now, apply the use of your tables. Get your 4-figure table. Open to logarithm of numbers. You can find logarithm of numbers in page 2 stroke page 3 of your 4-figure table. I know you know how to use the 4-figure table. You must have been taught from SS1 and SS2, or go to our DVDs for SS1 and SS2. You'll be taught how to use the 4-figure table. By adventure, you don't know. Log of 6. 6 is 1 digit. That means whatever you get from the logarithm table will be 0 points. You cannot see 6. That means I'm going to find 67, 7, 8, 2. It's not going to be divided by the log of 2. 2 is 1 digit. So whatever you get from each logarithm will be 0 points. You cannot find 2 in the log table, but you can find 20. So find 20 under 0. 20 under 0 is giving me 3010. Now divide out to get a grand finale. Just use a calculator. 0.7782 divided by 0.3010 is giving me 2.58538. I want to round it to, let's